Hello everyone. So we are going to do all this topic whatever we have in our syllabus, but we will not follow this sequence. We will follow our sequence which make you to understand very easily and very fastly. So what we will do, we will cover all topics, no need to worry. So now we will discuss this one, okay? We will do this. If possible today we will cover all this topic. If not, we will cover at least what is MAC table like that one. This is the we have only theoretical topic this one, but we will do the lab also. We need to differentiate hardware and software switching mechanism, that is what is ceph, what is process switching, and what is MAC table. Just now what we discussed we are going to do in detail, and then we have the fib and rib also. So what is this, we need to describe in theory only, but we will do lab also. So now we will start. What we will do, we will discuss the first of all MAC, okay, MAC address, because just now we discussed in our packet tracer what is MAC like that. So this is a MAC address. First of all, what is MAC? Because in the any device, if you are using any device, it is having the MAC address. All the device is having the MAC address. So MAC is very important. It is a 48 bit. MAC is 48 bit. First of all, if you are new, if you don't know about the what we can say about the MAC and the basic, this one we will go from the basic. MAC stands for MAC address, MAC media access control, okay. It is used to identify the NIC card. Each and every interface of the router switch is having the MAC address, as well as if you see in our computer we will have the LAN card, that is also having the MAC address. If you have the Bluetooth, it is also having the MAC address. So MAC address is having different name also. Sometime we are calling that one as a physical address, sometime we are calling as a hardware address, and sometime we are calling as a MAC address. And it is a 48 bit. It is a 48 bit. MAC address is a 48 bit. It is divided into 24 bit as a OUI and 24 bit as a serial number. If you see, you need to remember, because sometime they are asking this question also. MAC address, what is MAC address and what are the different parts in this one. So first one we need to say 24 bits for OUI, 24 bits for the company serial number. And actually sometime if we have for troubleshooting purpose also, we will check the MAC. We will check the MAC. In the router we will use the command show IP ARP, so we will get the MAC address of the device which is connected. In switch also we will write show ARP or show IP ARP to get the MAC address. We are going to see that later. Now you need to remember MAC is nothing but media access control. It is a 48 bit. 24 bit for OUI. OUI is nothing but organization unit identifier, means this is 48 bit is representing the company, which company this LAN card belongs, or the interface which we are checking the MAC address, that interface belongs to which company. First 48 bit is representing that one. After that first 24 bit is representing that one, and the last 24 bits is like a serial number. Like if they use any number 1, 2, 3, they will increase that one. But starting 24 bits will be remain as a OUI. That is a organization unique identifier. So how we can check? Example, let me show you one MAC, and we can check with the website also. I will take let me go here in my command prompt. I will write here get MAC. Okay, get MAC. Get MAC. When I write get MAC, I will get the MAC address. Okay, this is a MAC address. This is a 48 bit hexadecimal number. MAC address is a 48 bit hexadecimal number. I will copy this MAC address. Example, if I want to identify this MAC belongs to which vendor, this MAC address belongs to which vendor, how I can identify? I can go to any website. Okay, MAC lookup. We have different website. We can write MAC lookup or MAC get Mac or some different name we have, like get Mac. I think this one. Let's see here. No, actually in the Bing it is not giving correct result. We need to check in Google. Let me write here get Mac. There is one website where if we paste any MAC address, we will get the vendor detail. This one, MAC lookup vendor, this website. If you go here, if you paste your MAC address, if you see this is Intel, okay, we are getting Intel. So this way we can track also the MAC address belongs to which vendor. Because my LAN card is from the Intel, that's why I'm getting Intel. If you take example, if you are running the VMware workstation, if you have virtual adapter, you can copy that virtual adapter MAC and you can paste, you will get the VMware, like different vendor name you will get. So let me show you that one. Maybe this is from the VMware. So I will paste here. And if you see, this is from the VMware workstation. So in the real scenario, if we have any issue, like customer or the user is complaining, they have issue with the device and they share the MAC address and the IP address. So we will take this MAC vendor website just to verify this LAN card is from which vendor, because sometimes they have the issue in the IP camera. So we will check this MAC belongs to IP camera, they have the IP issue, maybe they have the camera issue. So we can inform to the other guy who is taking the care of that one. But this is not related to the course, just I am giving you idea to have the idea about this one. Now you can remember, if you want to verify, if you have any MAC address, if you want to check this belongs to which vendor, you can use the MAC vendor and you can check. And the first, what we can say, first 24 bit belongs to OUI. OUI means the guy or the company which manufacture this card, and remaining will be as a serial number. And we have different name, we can call this one as a hardware or physical or fixed or bun address, different name we have. If we check in our LAN card here, let me check what they are showing here. If we go here in the LAN card, here network option, this one, they will mention here the MAC name they have somewhere here. See, this is Intel just now which we check, and what they are saying, the physical address. Okay, so as we are saying, MAC address is also known as physical address, and also it is called as bun-in address. In the PC we are calling physical address, in Linux machine we are calling bun-in address, in router also we are calling little different. So we have different names for the MAC address. Don't worry, if you say hardware address, that is also MAC address. If anyone is saying physical address, that is also MAC address. If anyone is saying as a fixed address or bun address, all are same. We will have the MAC address in the switch. And if you want to check the MAC address, how we will check, let me show you. Let me take one switch here. I will take this switch and I will on this switch, and we will take the console of the switch. It is loading. So we need to write show MAC address table, so we will get the MAC table. Show MAC address table. And if you see, I don't have any entry because we do not have any device connected to his. But what we have the VLAN and then MAC address and then type and the port. Means what we will have, this whatever they learn, if they learn any MAC address, that belongs to which VLAN and what is the MAC address and how they learn, and it is connected to which port. So if you see here what I am saying, MAC address table combination of VLAN ID, MAC address, MAC table and port number. Just now what we check, And how we will have the MAC entry in the MAC table? We can have dynamic address entry, or we can do the static. Static means we will do binding, MAC address binding we are calling. How we will do MAC address binding we are going to see now. Why we will use static or MAC address binding? Because if you have any server, if you have any one server, it is always connected and all the guys are accessing that one. So what we will do MAC binding for that MAC address, the server MAC address, because if entry is erased, switch is going to do the broadcast. So that's why we are going to do the MAC binding. So when we do MAC binding, he will not do the broadcast. But anyhow, first of all we will see some theory, then we will do the lab. So you will have more idea about the MAC table when we do the lab. So now what you will remember? You will remember, first of all you will remember the full form of MAC, media access control, and it is 48 bit, and it is divided 24 bits for the company and 24 bits for the serial number. It is having different name: hardware, physical, fixed address, burn address. We have different name for this one. And in the table what we will have the VLAN entry, MAC address, and the type and the port, whatever port we have the dynamic entry or the static entry. We can keep static entry also, because switch is going to erase the entry from the MAC table if that device is not active. When they will erase after 300 seconds they will erase, or they will erase after 5 minutes. So they will erase from the MAC table. So what we can do a small lab. I already wrote lab here. So same thing we can do this one. What we are doing in this lab, we are taking one switch and we are connecting the 4 PC. Example, in this scenario we are connecting 4 PC. 4 PC is having the 4 MAC address. 4 PC is having the 4 MAC address. So switch is going to learn that MAC address and he is going to store that MAC address. So we are going to do that one now, so you will have more idea. So what we can say, switch default aging time. So switch will remember MAC entry 300 seconds or 5 minutes. If that guy is not active, that machine is not active, he is going to erase his information, his MAC entry from the MAC table. And what we can say, contain address memory. Contain address memory is nothing but it is a memory where our MAC table will be stored. What we can say, contain address memory, CAM table, is a system memory which is going to store the MAC address table. MAC table is going to store in that one. And we have the TCAM. TCAM is internally contain address memory. It is also a memory with a high speed and it will work very fast. It is also going to store the detail about the MAC and the IP. So we will see now, we will do the lab, so you will have more idea. I wrote some comments here. So when you are doing the lab, before doing the lab, you can study this command. First command, what we are saying, MAC address table aging second. If you want to check, generally in the real scenario we are not going to change any MAC aging time. Whatever we have default we are keeping that one, but if you want to change in the lab purpose, we can change and we can do some modification. And different command we are using to check the static address if we have, and if we want to assign static, how we can assign. This is a command we are going to do. Maybe if you see this command you will not understand clearly. When we do, you will understand. And if we want to remove that entry, we need to write no. Whatever we will do in the front of that one, if we write no, it will remove from the system. And then we will write show MAC address table. With this one we will get the MAC address. And if you write show MAC address aging time, we will get the, what we can say, aging time we will get. And maybe you will have a doubt how many MAC address switch is going to store. If you want to check capacity of the switch, we can check. We can write show MAC address table count. And if you want to check whatever the switch is stored dynamically, we can write show MAC address table dynamically. With this one we can look. So we have different command. We are going to do the lab, so you will have the idea. So now in this scenario, what we will do, we will take one switch and we will take 4 PC and we will assign the IP address to the switch, and after that we will check the MAC table. So this is a lab already I created. I put all the output here. Now we will do the brand new lab. So for your study purpose, I will share these notes. So with this one you can do the lab also. So what we are doing here, first we are assigning the IP. Okay, just now what we done in the GNS EVNG, same thing we will do here, and we will save here, and we will check with this one we have this IP. What IP we assign? 192.168.1.1/24, and then we have 1.2, 1.3, 1.4. We have the 4 devices, and when we want to check we will write show MAC address table. So we will get whatever entry we have. This is a MAC address table. Just now what we are saying in the MAC address table, if you see here, what we are saying here, this one MAC address table is a combination of the VLAN ID, MAC address, and all this one here, this one, the one which we are saying in the theory. This is the practical one. If we see, we have the show MAC address table. So what we have, what is the VLAN of this entry, VLAN 1, and this is a MAC address, and this is a how they learn dynamically, and this is the interface. This PC or this guy, whatever, maybe this is a server, maybe this is a IP phone, maybe this is a IP camera, whatever the device is connected to this interface, that device MAC address is this one, and we learn dynamically. Switch is saying like this. And total how many we have? We have 4. If we want to do, like if we want to assign manually, like I am saying, we will do the MAC binding. Like you have one server. Example, if you see this scenario, you have one switch here. Okay, you have one switch here. What we learn, every 5 minutes switch is going to forget. Every 5 minutes. Example, I have one PC here, and I have another PC here. I have another PC here. I have another PC here. Now, example, this is a PC1 and PC2, and PC3 and PC4. So switch is going to forget after 5 minutes or 300 seconds. He is going to erase if the guy is not active. So if this PC1 is not pinging to PC2, he is going to forget. He is going to erase from his table. So after 5 minutes he is going to erase. But imagine you have one server here. Okay, you have one server here. Your manager told you this server is critical server. Always everyone is using. Try to do the MAC binding for this server to this port. Example, this is a fast Ethernet 0x0. And here, why we are doing this binding? What happen if switch forget? What problem we will get? If switch erase the entry from the MAC table, he will do the broadcast. First time when switch don't know any MAC address, he will do broadcast. Example, this guy sends some traffic to this guy. First time he will do the broadcast, and then he will learn this MAC address and this MAC address. He will store in the table. And if these guys are communicating, he will store in the table. But the problem, after 5 minutes, if no one is communicating, he is going to forget. He is going to remove the entry from the table. So we don't want, if anyone is accessing this server, we don't want to do the broadcast. Why we don't want to do the broadcast? Because broadcast is going to reduce the network performance. We will have the issue. We will not have the good network. We will have our network performance will go down if we have the broadcast. To avoid broadcast, what we are doing? We are using VLAN also. We are using VLAN. Why we are using VLAN? To reduce the broadcast in the network, because broadcast is not good. If imagine if you have 30 switch, okay, if you have 30 switch, each switch is having 48 ports. How many PCs you are connected? All PCs. Example like this, you have 30 switches like this, and all 48 ports connected. This one is connected, this one is connected, this one is connected. Or let me show you in another way, so you will understand very easily. Let me take here. If you see here in the packet tracer, imagine if I take more PC here, if I take more switch, more PC, if I take like this, if I connect here, if I have more PC, I am taking only for some PC here for the lab purpose, but imagine if you have more PC like this in your network. You have 30 switches, each switch is having the port, what we can say, each switch is having the port 40 ports or 42 ports, whatever ports you have available in your switch. So how much traffic? Early morning everyone come and they will open the desktop, laptop, they will connect. Let me show you. I will send one packet from here to here. I taken the simulation. Okay, I will take the simulation on. I will take one packet from here to here, and now if I play, let me play. See, it is because they have the entry here, but if we have the, and I did not put the IP here, I did not put the IP here to this desktop, that's why it is not showing. Let me put 192.168 1 dot, I think 5 we can put, but we will have the lot of traffic. If I put the IP for all the PC and if I do this play button, it see how many packets are going, so many packets we will have, so many broadcasts we will have. So what we will do to reduce the broadcast, we will create the VLAN. With the help of VLAN we will reduce the broadcast. How we will reduce? Example, if I put this interface from here to here in the VLAN 10, okay, so whatever broadcast is happening, it will happen only in this area. If I put this area, maybe 40 computer in VLAN 20, so whatever broadcast we have in this area only. And if I put here VLAN 30, whatever broadcast is happening, it will cover in this area. Same like this in this area, VLAN 40, so this area they are going to cover. So it will not disturb our network. This area broadcast will not go here and it will not go here. So our network will not go down. If we have lot of broadcast, our network will go down, because switch will forget after 5 minutes and again he will do the broadcast. To overcome these types of issue, what we will do? We will do the VLAN. That's why we are doing in the company, many companies creating the VLAN. What VLAN will do? It will divide the single broadcast domain into multiple broadcast domain. What we will say? VLAN is used to create the single broadcast domain into multiple broadcast domain. So we are dividing the single broadcast domain into multiple broadcast domain. And maybe some guys are having some issue how to create VLAN. No issue, we will check in our later, maybe this class or maybe in next class we are going to check that one also, how we can create the VLAN. But now let's see our lab, main lab, what we are discussing, where we have here, I think in the packet tracer or GNS we are doing. So let me do this lab, the lab which we are saying here, this one, we will do this lab now. Let's do this lab and we will see. So what I will do, I will take the one switch and then I will take the PC. I can take any PC. I will take the VPC, is easy for now. Later we can say another other PCs also. So I will take, I have one PC here, I have one more PC here. Okay, so I have 3 PC, 4 PC I have one switch. So we can do one lab here, so you will have more idea about MAC table. If you want, we can change this name also, like PC1. This one should be PC1. Now we cannot change, or what? PC1. Apply. Maybe we have some PC here already, somewhere here. That's why he is giving, yeah, we use this 2 PC. Anyhow, no problem if we have different name also. PC4 and PC4 and PC3 we have here, and PC5, PC6 we have here. So now what we will do, we will take this cable, we will connect here Ethernet and connect to E0 by 0. We will connect here E0 to E0 by, here click here E0 by 1, and from here E0 to E0 by 2, and then here E0 to E0 by 3. Okay, so what I am saying here, this is E0 by 0, this is E0 by 1, this is E0 by 2, this is E0 by 3. Okay, this is a switch interface. Now I will start the PCs. Let me start PC. I will take the console of the PC also. All the PCs I will do. I will start the PC. I will do the console of the PC. I will start the PC. I will take the console of the PC. I will start the PC. I will take the console of the PC. Okay, so this is here, and so now we will put some IP schema. I will keep here, example I will keep here 192.168.1.1. we will give this IP to this machine. Okay, I will make this duplicate. I will copy this here, or we will keep this here. Here we will give 1.2. okay, and here I will copy this one. I will take here, I will give here as 1.3, and then I will copy, duplicate this one. I will paste here 1.4. okay, so this is the IP we are going to give to this machine. You can do this lab in the GNS3 or EVNG, no issue. Okay, so now I taken already the console of this machine, so let me go to the PC3 and assign the IP address. I will assign the IP address here. I will check what is IP. Show IP. We do not have any IP. We have the MAC, so I will copy this MAC, so we will paste here. This is a MAC. I will paste this machine MAC. Okay, this machine MAC here. PC3 I think, so here I will paste. Yeah, so how we will assign the IP? I will write IP and then write 192.168.1.1/24. press enter and then write save. Show IP, write show IP, show IP, and then save. So this one is done. So now one PC is okay. What we have, you have disconnected because another connection was made. Okay, no problem. This one, this minimize. Okay, so this one we save the IP here. Okay, now we will do same thing for the PC. So I will write show IP, and I will write here IP and then 192.168.1.2/24. just I am assigning the IP. Okay, and we will save. I will save here. This one also done. Let me check everything is okay here. We assign IP, yes, everything is good. Let me copy this MAC address, and this is a PC4, so I will paste this here. Now let's do for the PC5. Show IP, and then we will write here what we can write IP and whatever address we want to give. 192.168.1.3 we are planning to give, right? IP, yeah, 3/24. so this is okay. We will write here show IP. So now we have the IP, and I will save this also, and I will copy the MAC here, so we can keep the MAC for the 5th PC. So I taken the MAC here. We will keep the MAC address here, and then we last PC, this is the PC6. We can write show IP. We don't have any IP. I will write IP, and we will give 192.168.1. what we give last 1.4 we will give /24. Let me check what we give 3. Yeah, so this is 4, and we will save this one, and after that I will copy the MAC from here and I will paste here. This is the PC6. Okay, so I will paste here PC6. So now what I done, just I assign the IP and I taken the MAC also. Example, this is a MAC of this machine and this IP. All machine MAC I have, so we can verify with the MAC address, and this PC is having 1.3, and this is a MAC of this PC. So now we can verify, we can check now. And let me go to the console of the switch. If I check here, show MAC address table, we have the entry, but in real we don't have entry. Here we have entry. When the guys are communicating, then only we will have the entry. So what we told, we have the command show MAC address table. Okay, show MAC address table. When we write the show MAC address table, we will get the MAC address, and it is having the VLAN number. It is having the VLAN number. By default, all the PCs belongs to VLAN 1. That's why we are having this, all are 1 here. And this is a MAC address, all 4 PC MAC address. And how they learn with dynamically. Means automatically they learn. We did not done by static. Means manually we did not configure. We are saying manually we did not configure this. Maybe you can say manually means static. Example, if your manager asks you configure this MAC address, in some scenario, not only for server, in some scenario what we will do, we will configure the laptop or desktop MAC address of managers to some particular port also. That is depending upon the scenario where you are working, which company. But now what we will say, static or dynamic. Static is known as binding also, like MAC binding we are saying sometime. In the company they are saying, can you do the MAC binding of this MAC to this port, like that they will ask you sometime. So how we will do that one, we will learn now. First of all, this what we are saying, this is the MAC address connected to the port E0 by 1. We can check where is the E0 by 1. This is a E0 by 1, and this is the MAC address. So this is okay, correct. And if you see E0 by 0, where we have E0 by 0, this one, and the MAC address is this one. So we can verify here and here, both are same. So yeah, we have correct entry. So we have MAC address. Now what we will do, we will check about the count also, aging time also. We will write show MAC address aging time and press enter. By theoretical, we are saying the aging time is 300 seconds, but now physically, or we verify also, practically we check now. What command we use? We use show MAC address aging time. Why we use this command? To verify the aging time of the switch. By default, Cisco switch is having the 300 second. By default, Cisco switch is having the 300 second. So what we will say? We will say that 300 second, or we can say 5 minutes also. 5 minutes, 300 second, both are same. And now if you want to check show MAC address table, just press question mark. If you press question mark, you will have lot of things. Like example, what we are saying, if you want to check the aging time, just now we check. If you want to check address, we can check, or count. Count is very important. We are using the count also. Why we need count? If example, if you want to check the capacity, if you want to check the capacity of the switch, this switch is supporting to how many MAC address, we can check that one also. How we will check? We will write show MAC address table count, and if you see, you will get here dynamically how we learn. Dynamic address count is 2, and static means manually we assign any address. No, till now we did not assign. Total how many MAC they learn? They learn only 2. Why they learn 2? They erase. Total they should learn 4. If you see, we have 4 entry, but now it is saying 2. Why 2? Because the 5 minutes is finished, they are not communicating, that's why it erased. Now we can verify again. If you want to check, like show MAC address table, and if you see, now we have only 1. After some time, this is also going to erase. Switch is going to forget. After 5 minutes or 300 seconds, he is going to delete entry from the MAC table after 5 minutes if they are not communicating, if they are not active. So what we are saying, show MAC address count. So with this one, this switch is supporting this many MAC address. He can store this many MAC address in the MAC table. Now if you see,
sir, I have a question. Sorry.
Okay.
But this total MAC address space has no relation with the number of interfaces a switch has.
No, no, no. Because if you remove the PC and connect another PC, they will store other MAC address also,
Okay.
and old MAC address also there for 5 minutes.
Okay. Okay.
Yeah. So now this switch can store this many MAC address. Now what else we can say? We can get here total dynamic, how many we have, how many static we have, and total we have. We can look here. Now what we will do, we will configure static, means manually we will add one MAC address. Example, imagine this is a server. Okay, let me change the icon. I think let's change the host symbol, and if we go here, go to any color here, let's check server is available. Yeah, this is a server, this one. So now your manager told you for this interface E0 by 3, always try to bind this server MAC address to this interface. No one is going to change, so we can reduce the broadcast here. Switch will not forget, always it will be attached here. So how we will do that one? So first of all, whenever we want to do any configuration, we need to go in the global configuration mode. So now I go inside the global configuration mode. Now I will write MAC address table, then static, and then we need to write here the MAC address. What is the MAC address of that? This is the MAC address. So I will take this one. This is the MAC address. So let me copy this MAC address from here to here, and then I will go here, I will paste here, and after that we need to give space, we need to write VLAN. Which VLAN? By default we have VLAN 1, so I am writing VLAN 1. Example, if you have the IT server and you are using in the 250 VLAN or 30 VLAN number, whatever VLAN you are using, you can write that one. After that we need to write interface, and which interface, what is the interface it is connected to. So switch interface, that is E0 by 3. So we will write E0 by 3 and then press enter. So this way we assign the MAC address to particular interface, and it will not forget. Switch will not forget, switch will not remove this MAC address. It will be there. Even if this machine is not communicating, he will keep that one. Show MAC address table. If you see here what we are getting that one. It is in the VLAN 1. This is a MAC address just now what we added, and this is the static. How this switch learn this MAC address, someone add manually, and this is the interface. And if any other computer is pinging, example, I will go here, I will ping here like this machine IP is 1.2, so I will ping 192.168.1.1. when I ping 1.1, now we will have this entry also in our MAC table. I will check here. Now we have two entry. We ping 1.1, pinging from where? We are pinging from 1.2. We are pinging from 1.2 to 1.1. So he learned two entry, this one 1.2 to 1.1, and this is we assign manually. Example, if you want to remove the manual entry, how we will remove? Just we will go in the global configuration mode, and whatever command you run, this one, bring that command and press Ctrl A. When you press Ctrl A, your cursor will move here, write no and give space and press enter. It will remove from the MAC table. Now if you see show MAC address table, you will not have that one. If they are communicating, then you will have that one. So this is the command which we use to add manually if you want to add. So this I will stop this